This is shop talk. A part left the chuck at 2800 RPM and put a dent in the shop wall. The cause was one G code, G96. Programmer wrote G96 for the face. Tool walked towards centerline. Spindle climbed past chuck-rated RPM. Jaws, let go. The fix was one line. G97 with a hard RPM. That's the whole video, but you need to know why. G96 is constant surface speed. You tell the control how fast the cutting edge should move across the material, usually in surface feet per minute. The control does the math. As the tool moves to a smaller diameter, RPM goes up to keep that surface speed constant. That's the trap. Surface speed stays flat. RPM does not. As diameter shrinks, RPM climbs, and there's no upper limit hiding in G96 itself. Near centerline, the math goes to infinity. The motor doesn't care. The chuck does. Every chuck has a max safe RPM. Past it, centrifugal force overcomes the jaw grip and the part walks. Then it leaves. That's what G50 is for. On most Fanuc-style controls, G50 with an S value clamps the spindle. CSS can ask for more. The clamp says no. It looks like this. G50 S2000, then G96 S400. CSS can run wild until RPM hits 2000. If your program runs G96 without G50, you're trusting the geometry to never get small. That trust is what dented the shop wall. G97 is the other half. Fixed RPM. You tell the spindle exactly how fast to turn, and it stays there regardless of diameter. Most operators run G96 by default. Half their jobs should be locked to G97, and the chuck manufacturer agrees with me. 3 jobs demand G97. Drilling on centerline, threading, and any time the tool is at or near the spindle axis. Drilling on centerline. The drill cuts at one fixed diameter, its own. CSS would tell the spindle to spin at infinity. G97 says no. Threading needs constant RPM, so the feed per rev math holds. If RPM changes mid-pass, the thread pitch drifts. G97 keeps it honest. And anything close to the axis, small bores, parting, centerline finishing. G97. Pick an RPM that gives reasonable surface speed at the average diameter and live with it. Everywhere else, OD turning, facing on big stock, roughing, G96 wins. Better finish, even tool load, consistent chip, just cap it with G50. If you've made it this far, write G50 above every G96 line. Use G97 for drilling, threading, and centerline work. That's the whole rule, and it keeps parts in the chuck. Subscribe for more shop floor explainers.